Today we are going to move on to solving two-step equations. Recall that the order of operations ensures that numerical expressions such as 2 times 5 plus 3 have only one value. To reverse the operations, undo them in the reverse order. So we know that we use, please excuse my dear Aunt Sally, or PEMDAS, to follow a certain order of operations, where we would do parentheses followed by exponents, followed by multiplication and division from left to right, and then addition and subtraction from left to right. So to solve the problem 2 times 5 plus 5, we would start with the 2, and then we would multiply it times 5, because multiplication comes before addition. That would give you 10. Then you would add the 5, which would give you 15. To undo that, you're going to do things in the opposite order and doing the opposite. So the opposite of adding is subtracting. So we would subtract 5, which would then give us 10. And then we would do the opposite of multiplying, which is dividing. So we would divide 10 by 5, and that would again give us 2. So to undo something, we have to do the opposite, but also in the opposite order. So let's take a look at equations. A two-step equation, such as 2x plus 3 equals 9, has two different operations, multiplication and addition. To solve a two-step equation, undo the operations in the reverse order of operations. So first, you would undo addition or subtraction, and then you would undo multiplication or division. So basically, what we would say is we are going to use not PEMDAS, but SADMEP or SADMEP, which is PEMDAS backwards. So we would do addition or subtraction first, followed by multiplication, division, and then exponents or parentheses when those things come up, which they are not going to today. So let's take a look at example number 1, and I'm going to rewrite the word SADMEP here. It says solve 2x plus 3 equals 9. We know that we would do multiplication before we do addition if we were doing the order of operations. But when we are solving equations, we want to do the opposite of what we see and in the opposite order of what we would normally do. So we would want to take care of anything that has to do with addition or subtraction first. So we can see here that we are adding 3 to x. The opposite of adding 3 is subtracting 3. So just like what we were doing with this, we're saying x plus 3 equals 9. We would do the opposite of adding 3, which is subtracting 3, on both sides. Positive 3 and negative 3 are opposites and would equal 0. So we will cross them off. We're going to drop down the 2x that we have left. We'll drop down our equal sign, and 9 minus 3 equals 6. Now you will see that this is just a one-step equation involving multiplication and division. Multiplication and division is what we would handle second in a two-step equation because it comes second in our reverse order of operations. We see multiplication, so we're going to do the opposite, which is division. And we will divide by 2 on both sides. 2 divided by 2 equals 1, so those cross off and we're left with 1x, which is just x. And 6 divided by 2, which equals 3. So the solution for our two-step equation is x equals 3. Let's take a look at example number 2. It says solve 3x plus 2 equals 23. Again, we're going to use the reverse order of operations, SADMEP or SADMEP, and we're going to look at addition and subtraction first, followed by multiplication and division. So 3x plus 2, we need to get x by itself. We need to take a look at addition and subtraction first. So we're going to do the opposite of adding 2, which is subtracting 2 on both sides. Positive and negative 2 are opposites. They cross off and equal 0. I drop down the 3x. I drop down my equal sign, and 23 minus 2 is 21. Then I'm going to do the opposite of multiplying, which is dividing. And I'm going to divide by 3 on both sides. 3 divided by 3 is 1. 1x is just x. And 21 divided by 3 is 7. Take a look at example number 3. It says negative 2y minus 7 equals 3. Again, using SADME-P, we're going to look at addition and subtraction first. So we're going to look at this subtracting 7. What is the opposite of that? Adding 7. So we will add 7 to both sides. Negative 7 and positive 7 are opposites, so they will equal 0 and cross off. And I get negative 2y left on the left, and 3 plus 7 equals 10. The opposite of multiplying by negative 2 is dividing by negative 2 on both sides. Negative 2 divided by negative 2 equals a positive 1, so those cross off, leaving you with y. And then 10 divided by negative 2 is negative 5. And so then we just drop down our equal sign. Look at example number 4. It says 4 plus 1/5 r equals negative 1. So this one looks a little bit different. Number 1, there is a fraction in it. But number 2, take a look at the way they have arranged things. The r is on the right next to the equal sign. So that means it's being multiplied by 1/5. The 4 over here on the left is still our constant. It is just because it's coming first in the problem doesn't change its role. It is not being multiplied by r. It is being added to 1/5 r. So in our reverse order of operations, SADMEP or SADME-P, we are still going to look at addition and subtraction. So we're still going to get rid of the 4 first. The 4 is positive, so I'm going to subtract 4 from both sides. So that positive 4 and negative 4, being opposites, would cross off and equal 0, leaving me with a positive 1/5 r equals negative 1 plus negative 4, because they're both negative, gives me negative 5. Now, we have to get rid of multiplying by 1/5. We know the opposite of multiplying by 1/5 is dividing by 1/5. But remember, when you divide by a fraction, we do so by keeping the first fraction, changing division to multiplication, and then flipping our 1/5 over to its reciprocal, which would be 5/1. So we keep, change, flip. So I'm going to keep the 1/5 that's with the r. I'm not going to divide. Instead, I'm going to change to multiplication, and I'm not going to divide by 1/5. I'm going to end up multiplying by 5/1. The way to get rid of multiplying by a fraction is to multiply by its reciprocal. And I'm going to do that on both sides. Except when I multiply by 5/1 on the right, since negative 5 is a whole number, I'm going to make 5/1 into a whole number as well. 5 divided by 1 is just 5. So I end up with 5/1 times 1/5. Well, we know when we cross simplify that those would both equal 1, and 1 divided by 1 is just 1. So I end up with 1r. And then on the right, I get negative 5 times positive 5, which will give me a negative answer, and 5 times 5 is 25. So r equals negative 25. You will see that there are 6 letter problems here on page 471. On page 472, it says, Toya had her birthday party at the movies. It costs $27 for pizza and $8.50 per friend for the movie tickets. How many friends did Toya have at her party if she spent $78? So remember, when we do a word problem, we need to find the variable, which is the thing we're looking for. We need to find a total, which is going to be by itself on one side of the equation. And then we could find coefficients and constants. And up to this point, we've only had a coefficient or a constant. But today, because this is going to be a two-step equation, we are going to find that we have both. Let's ask, what are we trying to find? It says, how many friends did Toya have at her party? So we're looking for the number of friends. So what I would say is make your variable f to equal the number of friends. Then we can start looking at the other facts. It says it cost $27 for pizza. Now, it doesn't say $27 for each pizza. It just says $27 for pizza. This is a one-time fee. They may have bought 3 pizzas. They may have bought 2 pizzas, depending on the cost of each pizza. All we know is she spent $27 for pizza. Since that is just a one-time fee, that would fall in the category of a constant because it's just going to cost her $27 once. And it cost $8.50 per friend for movie tickets. So it's $8.50 per friend. We know that if we have a number per something, that indicates the coefficient because that indicates multiplication. So $8.50 is going to be our coefficient, and it's per friend. So we know that we're going to multiply that times our variable f, the number of friends, which leaves us only the total. It says Toya spent $78. Okay, that's the total amount that she spent. So $78 is going to be our total. So when we write our equation, we're going to put our total $78 on one side of the equation. We know that the coefficient $8.50 will be multiplied by our variable f. And I'm going to just remove the 0 so it is not in there to confuse things because we really don't need it at this point. And then we have our constant. Now, we are totaling up the cost for this. So is $27 something I'm going to add to the cost of the movie tickets, or is it something I'm going to subtract away from the cost of the movie tickets? Well, it's not a discount, so we're going to have to add that to the cost of the movie tickets in order to get total cost. So you can see here that our equation is $8.50 times the number of friends plus $27 for pizza equals the $78 that she spent on the party. To solve that, we would then again use our SAD/NP and go in reverse order of operations, doing addition and subtraction first, division and multiplication second. So the opposite of adding 27 is subtracting 27, and we're going to do that on both sides. Positive and negative 27 are opposites, and they cross off. So we get $8.50 times the number of friends equals $27 subtracted from $78, which is $51. Then we are going to divide by 8.5 or 850 on both sides because the opposite of multiplying by 8.5 would be to divide by 8.5. 8.5 divided by 8.5 is 1, so we get 1f, the number of friends, and then 51 divided by 8.5. And 51 divided by 8.5 comes out to be 6. Is having 6 friends at a birthday party a reasonable answer? Yes.